All right, so today we are going to continue on. We are talking about our rational functions. And yesterday we just had this defined. We said it is simply the ratio of two polynomials. And right off the bat, I use different letters here than your book does, if you guys happen to use your books. Why did I use N and D here? Numerator for N and denominator for D. Now, when we want to find the asymptotes of these things, which is really what we're doing, we saw that if I try to divide by 0, it breaks my function and that leads to an asymptote. That is that denominator zeros of it. We just take whatever this is and set it equal to 0 and we find our asymptotes that way. Now, for the other side of things, the horizontal asymptotes, and I am going to change color here because these ones are a little bit differently. Horizontal asymptotes, couple little statements about it. We can't have just a single thing, so if you're at the very bottom of your page, I would just flip it over because we're going to have a few different little things here. First thing, I want you guys to repeat and answer, and we'll just, part of my ceiling I just found on the floor, and I don't know why. That's weird. Okay. Can we ever cross a vertical asymptote? No. Can we touch an asymptote? No. So I know it's kind of cheesy, but we're going to do it. Real quickly, I want everybody to answer. Can we touch or cross a vertical asymptote? No. Now, that's what it means to be an asymptote, and the language here just isn't perfect. We can, and we will sometimes cross horizontals. Okay, verticals we will never touch. Horizontals we will sometimes. We're going to make a few little comments about this. Horizontal asymptotes, what these really tell us is truly, these are just end behavior. So we don't really care what happens in the middle of our function, anywhere near the origin, but specifically, if we're talking about end behavior, another way to word that is as x approaches what? If I want to know the end of my function, that's as I go really far left or right, and what am I approaching there? Positive or negative, right? So this is really what's happening as x approaches plus or minus infinity. We can, sometimes, we will, not super often, but we can cross horizontals in the middle of our graph. Okay, with this, some follow-ups about these, because there's a lot of them. We will check, or use rather, the degree of n, and I'm going to write it as n of x and d of x to help us. Now, entirely up to you, right? I always want you guys taking some form of notes, but you don't have to word for word write what I have. What is this? What is the degree of a function? Anybody recall? The highest power of the variable. So if you have that locked in, you certainly don't need to put this, but remember the degree is the largest power of variable. Okay. Now, as we're looking at these, without doing the long division, this is pretty easy to pick out. On the example that we did yesterday, it's probably, you guys have no idea how I did it. We talked about it a little bit, but when we graphed the one using the key features, I was able to just say, boom, here's our asymptote. It was really quick and really easy. When we're looking at these degrees, what's the possibilities? Is it possible that n is bigger? So something like x cubed over x, like we'll look at specific examples. We're going to consider all three possibilities. The first of these, and these are in no particular order, and I'm going to use a bullet point here, just I don't want it to be a dash to look like a minus. Okay, there are three possibilities with these degrees. The first possibility is that the degree, and I'm going to shorthand this with the DEG for degree, it's possible that the degree of my numerator is bigger than the degree of the denominator. Now, in this situation, I want us to think a little bit. We'll check out a graph in just a moment on Desmos. But let's think about what happens. Give me any sort of expression where the numerator has a larger degree. What do you want me to put in the numerator? Like, and in pink here, we'll just do an EG. X to what power? Sure. X to the third plus, I don't really care what's there. If I want something smaller than a third degree in the denominator, it could be x squared or x or none, right? Let's just say it's x plus something. This is the exact situation that we see. The numerator is bigger degree. Now, if we start thinking about numbers real quick, and we're just going to get kind of big, we're not going to get crazy big. If I plug in a 5, this is 125 over 5. That's pretty big. That's 25 already. What if I plug in a 10? 1,000 over 10? We just went from 25 up to 100. What if I plug in a 20? That's 8,000 over 20. Now we're at 400, and I'm getting bigger and bigger, right? The further I go, the bigger the difference between these is. Does that make sense? Or in another word, and this is not super formal, but do we all agree that the numerator gets bigger way faster? And if the top number in a fraction gets bigger, does it ever stop getting bigger? No. So will this thing ever mellow out around a value? And we'll look at this in a graph study. If that doesn't sit super comfortably, we will see this. In this situation, because the top gets bigger and bigger, faster and faster than the bottom ever does, this thing is no horizontal asymptote. There isn't one. And just to show us what this looks like, I'll pop over to Desmos real quick and just hopefully be able to convince you. Now, I just use plus ... because it doesn't even matter what the square and the x do. I see the numerator gets bigger faster. So if we look at this, and I'll make it so the whole screen shows, it's going to look really weird. Somebody suggested a YouTube channel that I'd never heard of, so there's a whole lot of weird stuff over there. It's not really that weird. What is it? Zach D Films, do you guys know that? Never heard of it until this morning. But let's check one. F of x equals, we'll call it x cubed plus 2x plus 3. And I got to put parentheses around it. And we'll divide this by something nice and easy. We'll just do x squared. Is the numerator, and we'll just do x, is the numerator bigger degree than the denominator? So if we look at this graph, and I might have to zoom way out. Why is it not showing up? Because there's an exponent over x. Okay, we'll make it bigger than that. 5x squared. Okay, as I look at this graph, as I go further and further right, does it ever stop getting bigger? No, it's just going to keep going up and up and up forever, right? There's no value that I kind of mellow out on. There's no horizontal asymptote there. Okay, give me another possibility. Gosh, this picture just gets me every time. So we're just going to close that so it quits distracting me. The degree of the top could be bigger. What's another possibility? If we're comparing the degree of the top and the bottom, the top could be bigger or the bottom could be bigger. So I'm going to switch colors just so it stands out. Let's just see what happens there. If it so happens that the degree of the denominator is greater than the degree of the numerator, and we'll just swap this around here. Let's say in our nice EG, it's just x plus who cares what's up here over x cubed. What gets bigger faster, the numerator or the denominator, Lando? The numerator gets bigger faster on our second one? Denominator. So let's do the same thing. Let's pick some numbers. If I'm at 1, I get 1 over 1, right? So that's not very big. But let's pick a bigger number, 5. It's now 5 over 125. That's like 1/25. Like that's pretty small already. If I pick 10, it's 10 over 1,000. That's 1/1000th. I'm getting smaller and smaller. What am I going to get really close to as I pick bigger and bigger numbers? 0. So what we see here in this situation, it's super easy to pick out. If we have the degree of the denominator is bigger, then we simply have a horizontal asymptote, and I'll switch back to the same color. The horizontal asymptote is going to be at the line y equals 0. And we've seen this already. The parent function, the reciprocal function that we've dealt with, 1 over x, has a degree of 0 over a degree of 1, where the denominator is bigger, and this is exactly what happened. We saw an asymptote, a horizontal asymptote at y equals 0. And we'll check it out over here real quick, just to verify, and it doesn't matter what our function is. We can pick x plus 1 divided by, we'll just do x over x squared plus 2. Now, if we look at this function, and I'm going to go home so it looks nice again, it does this wonky thing, but as I move further and further to the right, do my y values get closer and closer to 0, seemingly? Yeah, and then this is a nice example for a very particular reason. Horizontal asymptotes, can we cross those ones? Yeah, they only tell us about the end behavior. And in fact, if we just scroll a little bit over, does it look like, does this cross over that horizontal asymptote? It does, and that's okay because horizontals just tell us about the what behavior? I'll bounce over here. The end behavior. It only tells me what goes on at infinity. Okay, so we saw if the numerator is bigger, there's no asymptote, no horizontal anyway. If the denominator is bigger, it's a line y equals 0. There's one more possibility for us. The top could be bigger, the bottom could be bigger, or they could be equal. So for the equal category, what I want you guys to do is we're going to play around on Desmos, and we can either play on Desmos just up on the screen, or I assume, do several of you guys have calculators in your bags already? No? Weird. I wonder where all my calculators have gone. I'm missing like 30 of them, and they'll turn up eventually. But we'll do it on Desmos then. Okay. Let's say the degree of d is equal to the degree of n. They're exactly equal. And since we'll just stay consistent with it, let's do a quick EG here. Maybe it's 3x squared plus who cares over 2x squared plus who cares. Both of these are degree what? 2. Now, in this situation, we're going to play around with this. We're just going to make it as nice as possible. We're going to have in the numerator, let me get all this cleared. Let's say we have ax squared plus 2, and we're just going to make sure they don't factor out together, divided by bx squared. Okay, we'll make a slider there. So right now, if they're both 1, here's what my graph looks like. And here's what I want to notice. This is 1x squared over or plus 2 over 1x squared. So a and b are the same. And I won't do the sliders because I think that might make it confusing. If I do this and I zoom out on the graph, we'll just get rid of the sliders. Does this graph seemingly have a horizontal asymptote on it? Now, is there anybody here who's not really sure based on this graph whether it does or doesn't? So check it out. If I ask that question, all I'm saying is, does it look like there's a single y value that I kind of mellow out at? Like there's a horizontal line that seemingly it just turns horizontal, right? There's a y value that I'm approaching. Right now, we can't really tell what it is because the scale's too big. But if I drag this point around, if we look at the y value, what does it look like I'm getting really close to as I go to the right? It looks like 0? So maybe it's getting smaller, right? And right now I'm at 1.0016. Let's go further. Does it look like that y value is getting quite to 0? What's it getting to? 1. Huh. Okay, so that's different all of a sudden. I'm going to change one value here. I'm going to change this to 2 instead. Now we're going to do the same thing. My graph looks almost the same, and we'll go to the left this time. I want you to tell me what y value do we get close to as we go further and further and further. Now it's a 2. Well, what if I make this like a 5 in the bottom now? Oh, I lied. We're going to make this a 15 on top and a 5 on the bottom. What does it look like I'm getting really close to now? How is that happening? How can we work out the rule here? Say that louder, Naomi. It looks like it's just 15 divided by 5, right? Well, let's try again. Let's do another one. 15 divided by, I don't know, if I do 5, we'll do 5 over 10. If I can see that the leading coefficient is 5 over 10, what is that as a fraction? 1/2. Now, let's just do some checking real quick. I'll just check my function here. Is this getting really close to 1/2? Hey, we have a shortcut we can use. In the situation where these degrees are equal, the horizontal asymptote will always be, always, h, and I don't know why that was lowercase, ha at y equals, and this is the ugliest part that we have to write. How do we work out what we just did? Like Naomi noticed it was 15 over 5, and she was able to tell me it was going to be 3. What is she comparing there? The what coefficient? The leading coefficient. So if we want to be able to write this line as just some horizontal line, it's simply the leading coefficient of the numerator, and we'll just say of n, over the leading coefficient of d. And every time this will happen. Now, it is really nice in this form. If we have the other form where we've done the division and stuff, and it does not look like this n over d because we've actually done the division, we can't use this shortcut. We instead have to use the transformation stuff to say it's moved up or down or whatever the case is. This is faster. This is easier. This is more efficient. Okay, so without doing a ton of graphing, here's what I want us to do. We're going to use this and get practice with it. So before we continue on, questions about any of these horizontal asymptotes? So any question? Michael, question? Comment? Compliment? Hey, thanks. Cool. All right, let's check it out. So I have a couple problems for you. All I want you guys to do for me in this example is I want you to find horizontal asymptotes or horizontal asymptote and vertical asymptote. And there might be more than one vertical. In our world right now, we will not have more than one horizontal. So that's pretty convenient. And let's take a look at a couple of these. So on A, we have the lovely rational function, g of x, let's say is x squared minus 5x plus 6 divided by 2x squared minus 10. Now, I am not making you guys graph this right now. That's not our intent, but realistically, if we have the asymptotes, we could graph it and sketch it at least pretty quickly. We could do the long division stuff, but we don't have to. If I want to find vertical asymptotes, how do I do it? It's where what happens. And Julie, I see you checking your notes, so whenever you find it, if you want to shout it out, that'd be awesome. Where do vertical asymptotes occur is a question. Zeros of the denominator, right? So whenever we're approaching these problems, a good first approach, no matter which method you go, and I'm just going to put it here, we don't normally do this. Step one, your goal should be to simplify. Now, what that's going to entail is if we have to factor stuff, we will. And the good news is we spent a ton of time on factoring, so hopefully this is kind of in recent memory. Let's just try to rewrite g of x in its factored form. How do you guys feel about factoring right now, coming in cold after 3 weeks of not doing it? Do you want 60 seconds to factor that thing down, or do you just want to do it together? Okay, thanks, Mark. Okay, so let's look at the numerator first. I'm going to run through my factoring list. First thing I always check with factoring. GCF, is there anything that goes into 1 and -5 and 6? No, nothing meaningful. It's not a binomial, so I jump right to trinomial. Chetty, do you recall what we check first if it's a trinomial? And awesome. Is it? Fantastic. So as soon as we're looking at this and I see that the leading coefficient here is a 1, what do I have at my disposal? There's a shortcut. I now need to multiply 1 and 6, and I need to find two numbers that multiply to be 6, but add up to what? Positive 5 or negative 5? Two numbers that multiply to 6 and add to negative 5. Negative 6 and 1, those multiply to be negative 6, though. So I'll go ahead and do some scratch work over here. We have x squared minus 5x plus 6, and we would have a 6 here, right? It's not 6 and negative 1. It can't be that. They both have to be positive or they both have to be negative. So that didn't work. Other options? One more time. 3 and 2, I assume. But what do these add up to right now? Positive 5. What do they have to add up to? Is there an easy fix? Let's make them both negative. So by doing this in that scratch work, whether it happens like as actual scratch work or if you're capable of factoring in your head, either one is fine. I'm just going to rewrite g of x. I have a new numerator. Instead of this trinomial, I now know that it's x minus 3 and x plus 2. Or just kidding, x minus 2, I'm sorry. All I've done is I factored. I'm not changing anything other than the way that it looks. How about the denominator? Does it factor at all? A 2 comes out, and it leaves a what? X squared minus 5. Now, in doing this, we're doing a couple things. The first thing that we're going to wind up seeing here is if we were actually graphing these, we hope stuff falls out and divides out because it means we have a simpler function to deal with. Nothing divides out here. That's okay. Once we have our original form, and it's super easy to see the degrees, and we have this factored form, the rest of this is going to come pretty much right away. If we want to find the vertical asymptotes, Julia told us a moment ago, or reminded everybody hopefully, that the vertical asymptotes happen at the zeros of the denominator. What's my denominator in its most simplified form? 2 times x squared minus 5. If I wanted to make this 0, and we'll use a little bit of scratch work, and I'll just comment here, zeros of the denominator. I already have it here, so I won't write that. But if I tried to do this, 2 times x squared minus 5 equals 0. Can we find where that happens? What's the first thing you would do, Hawaii? Okay, I'll divide each side by 2. Done. I'm also going to add 5 to each side right off the bat. And here we are. Amy, if I want to finish solving for x, there's one more step. Let's take the square root. Now, I'll do the left side. It's just going to be x. And if you're going to make a mistake, it's probably going to happen right here. Michaela, anytime we take a square root of a number, what must go in front of it? Love it. Plus or minus. Now, these are not nice numbers, but there's 2 of them, and that's okay. These are the zeros of the denominator, right? We just factored and solved just this piece. Check it out. That's exactly our answer. Our vertical asymptotes, of which there are 2, occur at exactly x equals positive root 5 and at negative root 5. If you want to write it as a single plus or minus root 5, I have no issue with it, so long as they both show up on your graph if we have to graph it. We are done with the vertical asymptotes. It's just the zeros here. Now, the horizontal asymptotes, we could have answered before this, and in fact, it's easier in this form, I think. Michael, you agree with me. Why? Yeah, I can see these degrees really clearly here, right? It's a degree 2 because it's x squared, and it's a degree 2. If they're equal, my horizontal asymptote occurs where? Or how do I find it? If the degree of the numerator equals the degree of the denominator. Kennedy, we made eye contact for a brief second there. What did our comment say if the degrees are equal? Where's the horizontal asymptote? So the way that I would word it, and it's a mouthful, the ratio of the leading coefficients. They are equal. What's the leading coefficient at the top? So you're looking at these ones, right? What's the biggest power of x up here? X to the... And what's the number right in front of it? There's our numerators. And what's the leading coefficient of the denominator? Good. Our horizontal asymptote should be at 1/2. Now, when we put all this together, the numbers are kind of gross, but we could sketch this function very, very well with this. More so, if we look at the key feature stuff that we saw yesterday, one of the key features that we did was the zeros of the numerator. In this form, can I see them? I know it's going to cross at x equals 3, because that's this 0, and it's going to cross at x equals 2. Let's let Desmos do the big lifting here and see if our graph does exactly what we're saying. So we have x squared minus 5x plus 6. Of course it does that. X squared minus 5x plus 6. What's the denominator? 2x squared minus 10. Okay, so we'll go back home. Right off the bat, how many vertical asymptotes do you guys see? Vertical lines that it seems like we just never touch. I think there's 2 of them. I think there's one right here, and there's one right here, and I think I see both of them. Now, I don't know what the square root of 5 is off the top of my head, but it's a little bit bigger than 2. Does this look like that vertical line is just a little bit bigger than 2? And a little bit smaller than negative 2, maybe? So those look like plus or minus root 5. I know that my function is 0 when the numerator is 0. What values of x make this numerator 0 once we have it factored, Fred? So sorry to just throw you in there. What values of x would make this numerator be 0? Positive 3 and? So these are the only 2 places I should ever see my graph touch the x-axis. Well, let's check. If I go back over here to my graph, and let's see. Well, gosh, there's 3, and the other point was 2, right? There they are. I can see both of those points on my graph. As I go really far to positive or negative infinity, where should my horizontal asymptote be? What did we find the ratio was of the leading coefficients? Zed, what you got? What's the ratio of the leading coefficients for this thing since my degrees are equal? So we're going to back up because you're going to have this, and on the spot it's always tough. What's the leading coefficient up top? And the leading coefficient downstairs? 2. So my horizontal asymptote, if I zoom all the way out, I should see my graph gets really close to 1/2 or 0.5. Does it look like it's getting real close to 0.5 and just never quite getting there? Same thing happens if I go to this side. I'm coming from the bottom this time, but I'm getting really close to it. I'm getting closer and closer, and I'm just mellowing out. Cool. We can make sense of these. This graph is kind of wonky. It does this weird little thing in the middle. The graphs will look weird. That's okay. All right. There was a lot of talking with that problem. Way more than it'll ever take you to do. Realistically, these problems should be like 60-second problems-ish, depending on how your factoring is. Let's try a couple more. I'm going to give you one more to knock out. With your neighbors, I want you to do the same thing. You're going to find me just the asymptotes. That's the goal. Okay. And we'll call this one B, and I'll just move it all the way up here. And I'm going to give you guys a moment to do this one. Are y'all rusty with factoring stuff? Okay, so I'm going to give you one that we should probably be kind of rusty with then. So let's see here on B, we're going to have f of x. Let's say it's x squared minus 9 over, we'll call it x squared plus 6x plus 5. I want you to find for me, and I'm going to add one more little tick in here for you guys. I want you to find me in this function, if there are vertical asymptotes, where do they happen? If there are horizontal asymptotes, where do they happen? And the last one is if there are zeros or x-intercepts of this graph, where do they happen? I'm going to give you guys like 2-ish minutes. I'll be walking around so that if you're struggling with the factoring stuff, let's knock it out. Questions before I pause the video? Oakley dokley. Cool. As we go through, before I rewrite anything, I think it's reasonable that we might just answer the horizontal asymptote question right here and right now. Fred, I've already called on you. Eli, what's the degree of the numerator? So you gave me the whole numerator. What's the biggest power of x that shows up there? The degree. 2. What's the degree of the denominator? Anybody? 2. They're both 2, right? 2 and 2 right here. They're both x squared. What's the leading coefficient on each of these? 1. So it's just the ratio of those things. It's 1 over 1. When you're writing this, don't count it wrong, but I will take off minimal points just so you know on tests. If it's a horizontal asymptote, you better give me a horizontal line. How do I write a horizontal line? It's not just, I wouldn't write just 1. It's y equals 1. And I want you to make this a habit. Be very clear that it's a horizontal line. Okay, we can knock that part out. It's just that ratio. Now, on this one, I'm going to save a little bit of space compared to last time. I'm just going to rewrite the factored form immediately next to it. So let's see. This, there's no GCF. Is it a binomial? Do you know the square root of both of them? Is it a difference? So this is a difference of 2 squares. I can factor this using our lovely shortcut stuff. What's the square root of this? X minus, what's the square root of this? So x minus 3 is one piece, and the other? X plus 3. Okay, downstairs. I need factors of positive 5. I'm going to use a shortcut for this. Factors of positive 5 that add up to 6. Positive 5 and positive 1, right? So we have x plus 5 and x plus 1. In this entirely factored form, we get all the other information we need. The zeros of which piece give me my vertical asymptotes, Liam? Where do I find my asymptotes? From the numerator or denominator? Good, from the denominator. It's whatever makes me divide by 0. Kyle, what values of x make the denominator 0? So 0 won't do it because that'd be 5 times 1. Let me rephrase this. The denominator has 2 pieces right now, yeah? What value of x makes this part 0? Just the x plus 5. So if you're struggling with it, you won't here in a second. We're going to clear it up real quick. If I try to do this, and when I'm asking that question, we'll see if you can see this. I'm really asking, what is the solution to that? Yeah, -5 is one of them. That's easy. That's one vertical asymptote. And since it's a vertical line, how do I write a vertical line? It's not y equals anymore. It's x equals. So Kyle just gave me -5 for one of them. Talia, what value of x makes this other part of the denominator 0? -1. And we now have our asymptotes for this thing. Last little part here. Lily, when's a fraction 0? When it's numerator or denominator 0? Numerator. Is there any value of x that'll make my numerator 0? Good. At +3? And is there any other one? Anybody? -3. With all of this information, I think we can sketch this graph very accurately. So let's take a look, just to confirm real quick. Or we could graph it just by hand. What do you guys prefer? Just take a look. Okay. So we're going to graph this function on Desmos, and we're going to see if all this information seems to agree. I'm going to make this a little bit smaller so I can see both of them. Hey, don't say mean things about Angel and Sebastian and Ronaldo. That was not nice. All right. Clearly I'm messing with them, right? Maybe not clearly, I guess. I don't know. Who knows? All right. So let's check it out. I will zoom back out, and we'll just alternate. I lied. This is going to be easier. So here's my lovely graph, and we'll zoom out. Okay. Where are the zeros that we claimed this thing has? So let's see. Does it cross at -3? And at +3? Anywhere else? Those are literally the only two places it will ever cross. And I know that. Okay. We claim that there are vertical asymptotes where? So let's see. Does it look like my x value is getting really close to -5 before it blows up to infinity? For sure. On this side, is it also -5 that I'm getting really close to before it shoots down to -infinity? Awesome. And here's my -1 value. I see it's same things happening there. I shoot skyward and downward at -1. And if I zoom all the way out and I just track these y values, what should I get really close to? What's my horizontal asymptote as I get toward the end? 1. Does it look like my y values are getting closer and closer to 1? For sure. How about over here? For sure. All of that information is right here on the graph, and we can get it all really quickly just by factoring. Okay. Looking at these things, I'm going to give you guys a little bit of time to work on the stuff, so if you have questions, you can ask. We have like 12 minutes right now. Let's go ahead and, with a little bit of time, see if we can't get a head start on the assignment. So tonight, in study hall, at lunch, at home, wherever you're going to do this, I want you to start working on the following assignment. We're going to call this homework 4.2. And you will find this waiting lovingly for you on page 196. And I want you guys to knock out problems 10, 15, 17 through 23, and 34. Okay. Read very carefully. If it just says identify the asymptotes, I would not spend all the time graphing it. If it says to graph it, I cannot stress enough. Don't just graph it on Desmos and try to copy the graph. That's not the whole point of it. It's not just to have the graph. I want you to make sense of what's actually going on. If you're struggling with graphing it, when can you come talk to me? Before school, after school, at lunch. You can shoot me an email and I'll probably answer it because I'm finally feeling decent again. But I'm going to give you guys 10 minutes to start right now. Let's get started. Cool. Yes.